Very warm greetings to the jury members. This is BRINDA of Beta Kati Judo, and I'm here with my submission for the contest RECode 2024. Now let's take a look at the problem statement. We're going to be given with an array of strings and a maximum width. So our problem, each line should have maximum width of characters. This is an example of justification. Let's see this problem with the help of an example. Now, let us consider this example. When is going to be 7 and the words are going to be, this is an example of justification. And the maximum width is going to be 16. Let us try the characters of each word for our convenience. This is going to have 4 characters, which is definitely less than 16. So let us add the second element is. This plus is followed by a white space will be equal to 7, which is obviously less than 16. So let us add another word that is an. If we're going to add 1, it will give us 10. 10 is also less than 16. So let's say we can add one more, right? If we're going to add example has 7 characters. So 10 plus 7 equals to 17, which is greater than 16 and not falling under the constraint. This we can't add example. Only 3 words, that is, this, is, and one, will be in the first line. Though this is an or justified to be in the first line, it's not quite add up to the 16 constraint. So we are going to add the sample or the left out spaces with white spaces. We're going to have 6 white spaces, which is going to be evenly distributed in across the line. When we are going for the second line, we'll be having example of and text. The same similar manner, the white spaces are going to be distributed. Here in the first line, the white spaces are evenly distributed, whereas in the second line, we can't distribute the white spaces evenly. Thus, the left or the leftmost attribute will be having the more number of white spaces than that of right, which is also given under our problem constraint. The last word should be left as it is. It is already justified. This is our problem. Let me briefly say it one more time. We're going to divide the lines such that in a way each line should have the maximum constraint of characters. If it does not make up to the number of characters, you can always add white spaces in between them. While adding white spaces, we should remember that it should be evenly distributed. If it's not evenly distributed, the one on the left should have more white spaces. This is going to be our solution for the given problem. Let's break it down. These are going to be my user inputs. N is going to tell me about the number of inputs, and the words is going to have a list of number of inputs that is given by the user. I have used a list comprehension for our convenience instead of using a for loop. Max width is going to be the maximum width of characters, which is going to be present in each line. And hence is equal to function. Here we are calling a function with the parameters of word list as well as the maximum width. In the previous slide, we have called a function. Let's see what this function is going to do. In the first line, we are initiating empty list, that is result, which is going to store all the final justified lines, which is going to give the instance of current line, and a counter variable called clen or else the current length. We're going to initiate it is as 0 in order to act as a counter variable. Now let's see how this loop is going to work out with the help of a test case for our convenience or for our better understanding. Let us take the same test case. So during the first iteration, we'll be having this with a length of 4. By adding clen, which is 0, plus 4 plus length of current list, that is 0, we'll be having 4, which is obviously less than 16. Thus, this does not satisfy the condition. we're going to execute the else part. In the else part, we're going to append I and increment the value of C length by length of I. We're going to do the same procedure for the second iteration. In the second iteration, the length becomes 4 and the updated list is this, and the length of current list will become 1 and the length of I is 2. So 4 plus 2 plus 1 is equal to 7, which is less than 16, does not satisfy the condition. Let's move to the else part. Since it does not satisfy the condition, we're executing the else part and appending is to the current list, implementing the value of C length. During the third iteration, we will encounter I is equal to n whose length is equal to 2 and the current list is updated as this is. This also does not satisfy the condition, so again we are going to append n to the current list. Now let's move on with the fourth iteration. During the fourth iteration, C length will be equal to 8 and the I will be equal to example and the current list will be having 3 elements. Now we are going to sum it up. We'll be getting 18, which is obviously greater than 16. So the condition is satisfied. Once the condition is satisfied, we'll be encountering this loop. This loop is going to help us to evenly distribute the extra spaces in order to meet the maximum width condition. In our scenario, 16 is the maximum width and the current length is 8. So 16 minus 8 is equal to 8. So 8 number of spaces are required in order to meet the condition of maximum width. Inside the loop, we'll be having this one condition of order 1 when j mod 0 is not a favorable condition. Thus, we're giving a constraint of R1. So this will avoid division by 0. Let's take a look into this loop with the help of the following example. As we can see here, current, the j value is going to be incremented from 0 and since we need 8 extra spaces, the loop is going to iterate for 8 times. During the first iteration, j will be 0 and 0 more anything, the remainder will be 0. So the current of 0, that is this, will be added with one space. During our current second iteration, we'll be having j value as 1 and 1 model of 2 will give us 1 as reminder. Thus, the current of 1, the current list with 1's index is. So, is will be added with 1 white space. So far, we can able to implement the same condition for 8 iterations. And during our 8 iteration, we'll be having j value as 7, which is 7 mod 2 will give us reminder of 1. So the element that is present at the first index is going to be is going to be added with 1 extra space. All the iterations, we're going to send the current with to the rest list. So the current rest list will look like this with extra spaces added and fulfilling the condition of maximum width. Once the maximum width condition is met, the first line actually contains 16 characters. And now we are moving on to the second line. Before moving on to the second line, we have update our current list as empty and counter variable to 0 in order to count the same 16 length constraint for the second line as well. Now we have successfully tackled our first line. Let's move on with the second line. The second line is going to start with example. Example has 7 characters. 7 is obviously less than 16. So we're going to append example to the current list. During a second iteration, condition not met, so we'll be appending off to the current list. During a third iteration, will be appended to the current list. So we are currently having current length is equal to 13. During the fourth iteration, 13 is obviously less than 16. If we are going to add justification, which already have character of 14, which is going to obviously exceed the 16 condition. This satisfies the if condition. We are moving into the inner loop in order to distribute the extra spaces. We're going to require 16 minus 13, 3 spaces to fulfill the given condition. Hence, we are going to run the loop for 3 times in order to fulfill the 3 extra spaces that is required to meet the maximum width of 16. During our first iteration, 0 mod 2 reminder 0. So example will be added with one white space. During a second iteration, off will be added with one white space. During a third iteration, example will again be added with one extra space. So the final rest line is going to look like example of text with evenly distributed white spaces. Once the loop is satisfied, we know that the last line should be left as such. So this is going to be the final justified array of this, which is going to be written and printed in the format of this is an example of justification, which each line having 16 characters as maximum width, including the white spaces, which will be evenly distributed with the help of the code as we have seen. Now let's take a look into the test cases and the duplications. As we can see here, we have successfully implemented the first test case using the given code and the given algorithm. With the help of same technique, we can execute the second test case as well. This test justification can be implemented in real life scenarios for alignment purpose. For Word document or any other alignment purpose, the same logic can be implemented. Now let's take a look into the time complexity. Let's discuss about time complexity. In the function, the outer loop is going to be run for bit O of n power times, and the inner loop can be run for the number of byte pieces that is required. In the worst case scenario, let us consider each word has a characters which is greater than maximum width. So each line is going to be act as a separate line or separate constraint, resulting in n number of times the loop to be run. It is the worst case scenario. By taking consideration, we can conclude that we actually the overall complexity of this problem or this particular code is big O of n square. Since the outer loop is going to be run for O of n, inner loop can also be run for O of n in worst case scenario. Thus, the overall time complexity is big O of n square. With this, I like to conclude my presentation. Thank you all for the patient listening. Thank you.